Welcome to another quick little video on the Satyr 4 build process. Got my Satyr 4s, been listening to them for a while, and I wanted to give, it's not a review on them and on their sound, because this is a do-it-yourself project here. I want to give a sort of take as to a couple notes actually on the build and everything itself, but also how you can start to work to customize them. So a couple things on the build. One, make sure you actually get the right cups and the right side there. Two, however, as you're doing the build, Brian notes that in a couple spots like here, he recommends using some blue Loctite on the screws. I actually ended up using blue Loctite on all the screws in the yokes and everything in the headband itself. It's great in that they give you nice articulation, but that motion, you want it to be nice and smooth. So you don't want to crank the screws down really hard, but you also don't want the screws to come out. So I recommend blue Loctite action on all of those bits there. This is then his standard strap that he's famous for. Super, super comfortable. Absolutely love that strap. At first I used the experimental strap. It's thicker here, and when it actually sits on my head, it turns out for me, for my head, nowhere near as comfortable. I stick with a straight one there. After that, though, start listening to them, and to me, to my ear, these were a bit too bassy. And one of the goals is to try to actually have an open back with bass. And so, yeah, okay, that could easily be. Wasn't quite to my taste. All right, we have different tastes. This is a do-it-yourself build. You built this. You get to then do things to customize then that sound if you want. So here, for example, in the blue is the actual response that he has here. I tell you what, let me actually get myself a little smaller. You don't need to keep staring at me here. This is the blue is actually on his squig, what it looks like with the 68 ohm resistor. The red is what it would look like, by my estimate, if you have no resistor in there. You just go straight. And then the green is what would happen if you have a 22 ohm resistor. So you get to choose what you want this response to be like. All right, bunch of folks you could tune out now. Let me actually, though, just kind of quickly show you how I went about and did this. And it all comes down to, I got a whole video on understanding amp and earphone impedance and what it does to the sound and how you can measure it and all this kind of thing. So what did I actually do for this? Well, the first thing that I did is I said, okay, let me go take the Satyrs and let me put them on the test rig and go and actually get the impedance curve. So this is using REW, and it's plotting out the impedance curve. And you can see there's a peak right here. This is the resonant frequency of the driver, basically. And then it comes down, flattens out, and then comes back up. All right, so this impedance is actually going to potentially be interacting with the frequency response. If you have a really, really low amplifier output impedance, it's not going to have any effect at all. But if you have a higher one, yeah, it's going to do it. Perceptually, what it's going to sound like is that you've boosted the bass and you've boosted the high treble. But it's actually having an effect, a bit of an effect. Well, let me make a horizontal line here around, on 1K or something. It's having an effect all throughout this range and everything as well. This is my measurement of it. It's actually the same basic curve that you get from the manufacturer. Yes, I can measure this. In the video before, what I've shown is how you can actually have a little spreadsheet go in and do something like compute the effects. If you have that impedance curve, you can then figure out what would be the effect if I have a high output impedance on my amplifier. Why the heck am I talking about an output impedance of an amplifier? I mean, we're talking about the resistor inside the unit. The resistor that Brian puts in series with the driver there, so you have the positive lead coming in into the resistor, then into the positive of the driver. That resistor is emulating having a higher output impedance amplifier. That's exactly what it's doing. So we can then run that same exact kind of thing and say, hey, here's what the frequency response would look like relative to if there were no resistor. And normalizing things at 1K here. Here's what it would look like if you had a 10 ohm resistor. A bit of a mild boost. Here's a 22, here's a 47, here's the 68 that Brian uses, and here's an 80. So we can see that this is the delta that you would expect to have, the filter that you are applying onto the frequency response. You can then do something like say, hey, tell you what, let me take that And let me load up into Squiglink here that effect curve. So I just make it in the spreadsheet there, I dump it out, I load it up here into Squig as a curve. I also load up one that's completely flat, and I say, hey, how can I equalize a flat response to this? All right, what EQ filters could I use? Oh, I'm going to have a 56 hertz frequency with a gain of 3 and a Q of 0.7, and that then gets this bass boost. But also, there's a little bit of a dip throughout all of it. What I'm doing in all of this here is I'm just applying filters to a flat curve to turn the flat curve into the effect of the impedance. And now that I have these numbers, I now know what that 68 ohm resistor is actually doing to the frequency response. And if I know what the 68 ohm is doing to the frequency response, what filter is applying, I can take this positive 3 gain and turn it into a negative 3 gain. And I can then go and remove it. I can then go and say, all right, this is what it would look like if I have nothing. And that's where I got to the red curve. Just using these top 3 creates this red curve, the 0 ohm curve. Well, all right, I can play that same exact game and I can say, all right, now let me keep those same frequencies, the same widths, the same all that kind of thing, just change the amplitude of it and go and have it match the effect, say, of a 22 ohm resistor. Take your pick. And then add that then back in. And that's exactly what I've done here. So now then, instead of just being able to see something like, oh, this is what the filter looks like, oh, imagine what this would do to the frequency response, you can take the squig of it and go and apply that. So I can now say, oh, by the way, yeah, that 22 ohm that by my ear I was saying, that's about what I want. This is what it would look like. Again, this is a do-it-yourself project. I think Brian may actually have a production run and be selling them at some point. I've seen some notes on Discord where he's been, at least he's considering that. I don't know that it's happening. This isn't some, big reveal or whatever. But this is yours. You have the plans for it. You built it. If there are things that you want to be a little bit different on there, go make them different. That's the great thing about the do-it-yourself kind of thing. I really like these headphones. I like them a lot. They're super comfortable. They're super light. And I was like, hey, I just want to tweak the sound in this little way here. Oh, here's a simple little thing I can actually do to do that. And by the way, as you're listening and you're trying to figure out what it is that you might want, I mentioned this kind of connector before. I love these little guys. So they're just little screw terminals. There's a female 3.5 millimeter. There's the male 3.5 millimeter. And all I've done here, my headphones were set up to have no resistor in them. I was listening to that, but I said, all right, let's see what they are. Let me take a couple of, in this case, say 22s. So going from the tip to the tip, or the left to the left, the sleeve to the sleeve with a 22 ohm resistor. The wire here is then just on the common. I've now simulated exactly what normally lives inside of the headphone cup. And I can now go and say, hey, what does this one sound like? I can then go and grab whatever resistor value I want and say, yeah, let me go and stick in there and see what it actually sounds like. So this way you don't have to keep taking them apart, unsoldering them and all that kind of thing. Jury rig something like this up. Boom. There you go. And with that, happy listening.